Okay guys, these are, this is some of the worksheets examples that we can use. Now these are not exactly the same as the one that you might have in front of you. I've done different versions of this worksheet over the years, but the key here is I actually just want to be able to go through with this with you and talk about how do we solve each of these types of problems. Alright, so these first ones, what we're doing is we're trying to write the equation that would satisfy the curve or the shape of the curve. And the way that we do this is by focusing on finding the zeros. Okay, and so you can see the zeros here are where we're touching the x-axis. So this would be -4, +3, and +6, I believe. So I might start by writing my equation, y equals. Now the first thing I should look for is that right arrow. If the right arrow is going up, it's positive. If the right arrow is going down, it's negative. So in this case, I have a positive equation. So again, I want to warn you guys, don't think that this question 1 is the same as the question 1 on the worksheet you have. There's lots of different versions. But on this example, okay, y equals a positive, so I'm not going to put anything here. I'm just going to start my first parentheses. And I need a parentheses for each of my zeros. I see I have 3 of them, so I'm going to need 3 parentheses. The first parentheses needs to have -4 as a 0. So I'm thinking, okay, what makes -4 be a 0? Well, an x plus 4 would mean that if I plugged a -4 into it, -4 plus 4 would give me 0, and that would work. So for me to have 3 as a 0, I would need to have x minus 3. And for 6 to be a 0, I'd have to have x minus 6. So we can see it's a positive equation, 3 x's or 3 zeros. So having an exponent, or having 3 different x's means my exponents will, my arrows will point in opposite directions. And that's what our graph is going to look like. So this is the equation that gives us the structure. Now, you know, how high or low it goes depends on a lot of things. But for this, that should be it. Let's take a look at another problem. Let's look at number 5 here. Here we notice that the right arrow is headed down. That means that my equation needs to start with a negative. Then when I start looking at what my x's are, I see I've got one over here at 2, 3, 4, 5. So this would be x plus 5 because it's a -5. I have to switch that sign when I put it in the parentheses. Then this guy right here is 0. So that would be x minus 0. We will rewrite this here in a minute. And the last one right here, that's 2, 3, 4. That'd be x minus 4 because +4 is the solution. Now there's a couple of things I want to address here. I don't like x minus 0 in the middle of the problem. It's not wrong, but it's not simplified fully. What we usually like to do with this guy right here is put him out as an x in the front. Now our problem was negative before, right? We were always negative. That's still there. But instead of writing x minus 0 later in the problem, we just write x out in front of our first parentheses. So this guy right here is the same as x minus 0. Okay? That's why that x is there. That means I have a 0 at 0. And then I have to have my x plus 5 still. And then I need my x minus 4. But there's a problem. Because right now when I look at this, I see 3 x's. Okay? Those 3 x's would mean that my arrows should point in opposite directions because 3 is an odd number. But the arrows are pointing in the same direction, which means I need an even number of x's. So what's going on? Well, if we look right here at this guy right there, we notice that it has a bounce rather than a pass-through. It's bouncing there, which means that there's something special going on. That's what we call a multiplicity or a double root. That means that this term is squared because it came twice. Okay? And so that's what's going to happen. Whenever we see this bouncing behavior, you can see it here, you can see it here, where it doesn't pass through, it just bounces. That's an indication that we have a double root or a multiplicity. Okay, so that's how we're going to do these when we're writing the equation from the graph. But most of our time is going to be spent taking equations and creating the graph. Okay? So like a problem like number 19 here, how do I create that graph? Okay? Again, I said this is different than the assignment that you're given. So if we take a look at question number, well, let's say take number 19. There's a series of questions that I'm going to ask and fill out. They're going to let me decide what the graph should look like in a slow, detailed format. Now, you guys can probably cut a lot of corners if you understand what all of this stuff means. Okay, I'll write it all down and then we're going to go through each of them. All right, so we start with the leading coefficient. The leading coefficient is the number in front of the whole thing. It's either going to be positive or negative. In this case, it is negative. That's all you need to know. Is it positive or negative? The next thing is the degree. The degree is the biggest exponent. Now the problem with the biggest exponent is if it's in this type of format where it's already been split and factored into parentheses, we kind of have to reimagine it multiplying back together. If we multiplied all of this together, you know, the x times the x would become x squared, and we have this x squared outside. If we multiplied all of these together, we would end up with something that's in the ballpark of x to the fourth. Okay, so because this is an x to the fourth, we can say that the degree of the polynomial is 4, which is even. Now all you really have to do is count the x's if it's in this factored form. 1, 2, because you got to double count the square, 3, 4. This tells me a lot about my arrows for my in behavior. Because the leading coefficient is negative, my right arrow is down. If the leading coefficient is positive, the right arrow is up, just like when we were doing the equation building. If it is even, the left arrow matches. If it's odd, the left arrow is opposite. So here the left arrow will match. So I'm going to have 2 down arrows. Zeros are the things that make each x equal to 0. Now I should be able to find, because I see 3 x's, I should be able to find 3 zeros. The x squared that's out here by itself will always be a 0. The x minus 6 would be a positive 6, and the x minus 2 would be a positive 2. Multiplicities are when one of the zeros or more of the zeros occurs more than once. In this case, the x squared is the same answer twice. That's what squaring does. It gives us the same answer repetitively. So 0 occurred 2 times. And that actually helps us account for where are the 4 answers. 0 is twice, and then 6 and 2. And then the number of turns is always 1 less than whatever your degree is. Since our degree was 4, 4 minus 1 is 3. So I should expect this to turn 3 times. Now all that information is information that I process, even if it's just internally, if I don't write it all down. It's all decisions that get made as we produce these graphs. I'm going to put a dot at 0, a dot at 2, and a dot at 6 on the x-axis. I know I'm going to be down on the left, down on the right. And something that I think helps for keeping track of information is whenever there's a multiplicity, I draw a little dotted circle around that value to remind myself that when I get to that number, instead of passing straight through, I'm going to bounce. And you can see that right in here where I'm bouncing instead of crossing through. I call that a Welch indicator because I made it up. Make up my own rules so I get to do my own thing. So this graph is going to come up. It's going to bounce at 0 instead of going through. Turn around and go through 2. Turn around and come down through 6. And there's a generic version of the graph. The last thing you're going to be dealing with on your homework, and I'll pull this one from your homework, are going to be problems that haven't already been factored. So questions like number 27 on the worksheet that I gave out this year says x cubed plus 3x squared minus 4x minus 12. There'd be a y equals there. Okay, I need to produce the graph, but this isn't in factored form. And since it's not in factored form, I'm going to have to factor it to find all the information. But I can find a lot of the information I might want before I factor. So that's what I'm going to do first. I'm going to find everything I can find from the original equation, and then I'll figure out how can I find the rest. Okay, so this is all the information that I usually find as part of my graphing process. And again, you don't have to write all this down if you know how to process the information. But my leading coefficient would be right here in front of everything, which there's nothing there, so I'm going to go ahead and say leading coefficient is positive 1. My degree is the biggest exponent if it's not factored. If it was factored, I would count the x's. But this is an x cubed equation, which makes my degree 3, which is odd. Because the leading coefficient is positive, the right arrow must be up, and odd means opposite on the left. So that will be down in this case. I don't know the zeros unless I get it into its parentheses form, right? And I don't really know how to do that right now. I do have options, but I don't want to do that right now if I don't have to. And the turns is 1 less than the degree. Since the degree was 3, I know there will be 2 turns. All right. Until I find the zeros, I'm stuck. But if you remember what we did in 5.6 and 5.7, when I asked you to find zeros, the first thing you did when you took equations like this, to find the zeros, you would have started by graphing. Now we could do this algebraically by factoring or doing synthetic division, but if there are some obvious zeros, I might as well go get them now. So I'm going to graph this instead of trying to factor it. Factoring still works, and I'll show you that in a minute, but this might save you a bunch of time and headaches if you get comfortable with the process of using graphing to help factor and help solve. I can see this looks like it crosses over here at -3, maybe -2, and +2. If I look at the table, +2, -2, and -3, you can see right here I get this 0, right? You can see where I clicked there a minute, click there, 3 zeros. So I know my zeros are -3, -2, and +2. So guess what? I don't actually have to factor this at all. Now, it's a degree of 3, which means there's supposed to be 3 answers. Is this all 3 of them? The answer is yes. So there are no multiplicities in this case. So all I have to do now is come over to -3, -2, and +2. My arrow to the left is down, my arrow to the right is up, and since there's no multiplicities, it's just a pass-through problem. I come up and through, down and through, turn around and go up through. And I'm done. That was it. Now let's say that you don't have a graphing calculator, or you're like, I want to still practice my factoring. You could have found those zeros by taking the original problem, x cubed plus 3x squared minus 4x minus 12. And I'm going to go a little quick here. If you already know what you're doing, you can move on and not worry about this. I'm going to use grouping in this process to pull an x squared out, which will leave me with x plus 3. And over here I would pull a -4 out, which would leave me with x plus 3 as well. That would factor further as x squared minus 4 times x plus 3. And because I have an x squared minus 4, which is a difference of squares, I can do an x plus 2, an x minus 2, and an x plus 3, which gives me zeros of -2, +2, and -3. The same 3 zeros we got by graphing. So graphing is a great way to find zeros to help you produce the graph. But let's talk about the downfall here. This graph was actually pretty easy, but do you see how it disappeared off the screen? If you get some of these, like say for instance I put a 2 in front of that x cubed and I graph it, a lot of it disappears off the screen. You might not know what's going on. And so it's important that you understand it's not enough to just throw it in the calculator and say it's always going to be easy to graph from the image there. Sometimes you're still going to have to figure out where are the arrows supposed to point, or is it connected along the way? Those are questions that come from doing this list of information on the side. Good luck, guys. I'll see you in class. If you have questions, come and ask.